In this video, you'll learn how to build a responsive CSS grid with only 3 CSS properties and without any need for breakpoints. We'll also do it in a framework agnostic way, so you can use this solution whether you're using React, Svelte, Angular, or just pure HTML and CSS. So let's get started. Here on the left we have our code, and here on the right we have our responsive grid. As you can see, the number of elements per column and per row changes depending on the available size for the grid. The responsiveness of this grid is controlled by the minimum size we allow each one of the elements to be. Right now, if you look at the CSS variable, you'll see that the minimum size we allow is 10 rems. What that means is that none of these elements can have less than 10 rems of width. Inside here, you can see the current width of the elements, and you can see that if we start resizing the grid, as soon as you get a little bit past the 10 rem width threshold, the elements will wrap. Same thing happens if we start shrinking even more the grid. Since we are using CSS variables, we can very easily just change the value from 10 rem to 12 rem, and now all of a sudden we'll have elements that start wrapping at 12 rem instead of 10. As you can see here. Another part of our layout that's configurable is the gap between the elements. If we change the value of the grid gap variable from 0.5 rem to 2 rem, we can see that the space between the elements is going to increase. Since the minimum size we want elements to be and the gap between the element is configurable to the CSS variables, it's really easy for us to reuse this in a lot of different situations. Now let's look at the CSS and see how exactly we are doing this. First of all, we set the display to grid, and to change the gap we set the grid gap to use the value of the CSS variable grid gap. The second parameter that you see here is the default value. That means that if we don't pass any value here, the value that is going to be assumed is the one that we define here. That's why you didn't see the grid space change, even though we removed that from the list of parameters in the styles. The most important property to understand this solution is the grid template columns. Here we are setting it to repeat, with the first parameter being out of it. What this means is that we want the number of columns to be enough to fill the available space of the grid container. To set the size of the columns, we are using the min-max function. If you're not familiar with the min-max function, it allows us to bound the value between a maximum and a minimum. The maximum value is one fraction of the space available, and the minimum value is the minimum between the min size that we defined in the CSS variables and 100% of the width of the grid container. You might be wondering why we need this min here. So let me show you what happens when we actually go and remove the min function from the min bound of the min-max function. So if we go here, you'll see that we get into a point that the width of the element is going to be lower than 12 rem, and then the container starts to overflow. And that's not what we want. We want to prevent overflows, so in situations where we only have one column, what we want to happen is for the elements to actually go below the minimum defined size. A simple way we can do that is with the min function. And that's exactly what we were saying. We were saying that we want the min value to be the minimum of the size that we defined in the CSS variables and 100% of the width of the container. So in situations where the width of the container is actually smaller than the defined min size, that will be the minimum value we will use in the min-max function. So now that we have reintroduced the min function in the min-max, you can see that even though we are going below the 12 rem, there won't be overflow.